Hello everyone. In this video we're going to cover clay volume interpretations. Danomics has methods available for V-clay from gamma ray, SP, Neutron, and neutron density as a dual clay indicator. Let's get started. So here we are on our key well, and we are in the clay volume module. So if you don't see this screen, come up here to the module selection menu and select clay volume. And then you'll be presented with the parameter table here. So we're going to click on Advanced so we can see the full parameter table. So we can see that there are options here for different methods, including gamma ray, neutron density, neutron, and SP. If we disable a method, we'll see that the parameters for that method disappear as we no longer need to enter those. You'll also see that for the gamma ray method, there are several sub-methods. So we have our standard linear gamma ray, as well as the nonlinear methods such as Larionov, Young and Old, Clavier, and Steiber. For tracking methods, we can set our lithology defaults. So for example, here we can set these up specific to our reservoir types if we want to do this. This is often useful for helping to track which lithologies you're interpreting and to help people follow your work. So the way I like to start off on this is I like to start with my dual clay indicator, and so that's my V clay from neutron density. And I find the easiest way to set the parameters is via a cross plot. So we can click on our cross plot tab here. And here we bring up a neutron density cross plot. So what we'll do here is we can expand out our settings, and we can choose which formations we like to look at, as well as if we want to filter out any data or apply color to our data. So I always like to color our data a little bit, so I am going to color it by our clay volume. So I'm going to type at VWCL, which is the volume of wet clay. And now we'll see that that colors our data here from the darker colors, which are very low V clay, to the lighter colors, which are higher V clay. And if we wanted to filter out data, we could do that as well. So for example, if we wanted to filter out data that was flagged as bad hole initially, we could go ! at bad hole, which essentially tells the software exclamation point is not, the at symbol calls out our curve, and then bad hole is the curve name. And we can see that some of the data disappears. However, since we repaired our curve data, this option really isn't necessary at this point. So when I'm doing this interpretation, what I like to do is start off with all formations visible. And I like to start off by setting my clay endpoint. So what you really want to do is you want to put this so that your line roughly bounds the data here. And we, if you knew your clay types, you could determine if you're an illite, kaolinite, or smectite clay, or some type of mixed clay system. So you can choose how to set that parameter. And notice that I'm moving this parameter, and it's making changes for all of my formations, and that's because I have all formations active, which is what I intend to do with my clay endpoint. However, I like to set my matrix endpoints separately. So what I'm going to do, I'm going to turn that off, and I'm going to say, well, I know my Alston chalk and my Buddha have, essentially have a limestone matrix point. So I'm now going to grab this, move it down here, and I'm going to set my clean point as well, and I'm not going to modify this clay point. So once I've set those, I see that they're now set here in the parameter table. So I'm going to turn those formations off. I'm going to turn on my Eagleford shell. The Eagleford in this area is predominantly a limey shell. So we can set that roughly on our limestone matrix. And then for the shallower formations, these are more siliciclastic. So, excuse me, here we can use a sandstone matrix endpoint and clean point. So once we have those set, we now have adjusted our V clay from neutron density. And in case you didn't notice it, as you move these points, the curve will update in real time. So let's put that back to where it is, and now you can see that change occurring. So now that we have that set, what we'd like to do is we'd like to set our gamma ray clean and clay points so that we get a good match between our V clay from neutron density and our V clay from gamma ray. So we can do this either via drag and drop or via typing in parameters. So to get started here, I'm just going to grab my gamma ray clay line and I'm going to slide this out. And what we see is as I move that, now the curve starts to align itself. And you may want to expand your template here so you can see what's going on better. So to do that, we just click on the little settings icon beside our gamma ray curve, and we can make that wider if we want to. So that makes the track wider, and we can also adjust the scale on that curve. See, so now that we've done that, we can just hide away those settings. And this helps us really focus in on how we want to tune this. So maybe we can slide this over just a little bit more to try and get the best match possible. And we essentially want to repeat this for each of the zones. It's always nice to get your starting point similar to where your last zone started off. However, in some cases, you're going to find that you need to change that. Here we can see that we're doing a fairly good job of matching the higher gamma ray values, but we're not matching the lower values from our V clay from neutron density. And so what we're going to want to do then is adjust our clean point. There we go. And now we see that we're starting to get a much better match from our V clay gamma ray to our V clay neutron density. And we'll continue this process. So here in the Eagleford, this is an organic shell, so we're going to want to move this point quite a bit higher here. And you know, you're never going to get a great match between these indicators and an organic shell, but you're just trying to get them as close as possible. And then we're going to come in and lastly set our Buddha, which is a relatively clean or a very clean limestone. So we're just going to set our clean and clay points until we get those to match as best possible. And so once we've done that, we now have a V clay. And you can see that we have here a final V clay. And you may be asking, well, what's the difference between the final V clay and the V clay from gamma ray and the V clay from neutron density? And the final V clay is determined to be either the minimum or the average of the selective V clay methods. And typically we always go with the minimum. That tends to work better across a wide range of lithologies and prevents you from overestimating your clay volume. Should you decide that you want to add additional methods such as the SP method, we can activate that. And then we'll need to tune that method separately. So for example, we may want to come in and set a default value in the parameter box here. And it looks like we're going to need to adjust this. So let's try and adjust it in one of our cleaner formations first. Okay, so maybe that's going to be about minus 50 there. Let's see how that looks. That gets us closer. And so now maybe we can try using that as our default for all the zones. And we see that we can get a reasonable match. However, I will caution those of you who are working in tight rocks or in unconventional systems against using the V clay from SP unless absolutely necessary. As in low permeability systems, it often does not give a representative answer or often gives an answer that is far too smoothed out. So we're actually going to disable this method even though we did take the time to calibrate it. So that's how we go about setting V clay in the Danomics Petrophysics platform. And as always, remember to save your work. And thank you, and we'll continue on with the next video.